Hello, you're welcome to today's class. I'm so excited. So today we're going to be talking about separation techniques. Separation techniques. So what's the essence of studying separation techniques? We study the nature and composition of a substance, and the substance must be in the pure form. In order for us to study the nature and composition of a substance, the substance must actually be in its pure form. It must not contain any unwanted substance or impurities. So without further ado, let's get right into the video. Okay, are ready to study the nature and composition of a substance? The impurities must be removed. Now the impurities are usually chemically combined with the main substance. Therefore, impure substances are regarded as mixtures. So to study the nature and composition of a substance, the impurities must be removed. Since the constituents of mixture still retain their individual properties, both the physical and the chemical properties, it's possible to separate the constituents based on their individual properties. So there are methods used to separate the constituents of mixture, and these methods are based on physical means. In other words, we are using the physical properties of these mixtures to separate the individual components of these mixtures. Let's look at some of the physical properties we use. We use size, we use solubility of substances in solvents, then boiling point is also a property, density, mixability, magnetic property, sublimation, and the rate of movement. So let's go quickly into the separation techniques. So number one, we talk about sieving. Now sieving is used to separate solid particles of different size. The mixture is placed on a sieve with a mash of a particular size. Smaller particles whose size is smaller than the mash size will pass through the sieve, while the bigger particle remain on the sieve. In other words, the physical property that is the determinant here is the size of a compound or the size of the substance we want to separate. Moving quickly, let's go to filtration. Now in filtration, we are separating insoluble solids. In other words, we are separating solids that are not soluble in water or any liquid, any solvent anyway. So the solid will remain in the filter paper and is known as the residue, while the liquid will pass through the filter paper and is known as the filtrate. If we look at that example, the diagram there, we are separating chalk suspension. We are separating it, and when that suspension is passed through our filter paper, we have what? We have water in the conical flask, and our chalk particle would be on the what? On the filter paper. Now let's look at evaporation. This method is used for obtaining a soluble solid from its solvent. So in other words, when we have a solid this time around that is soluble in water, an example of this is salt, a common salt, NaCl, diluted in water. How do we separate that? We separate that through what? Evaporation. So the mixture is placed on an evaporating dish, and what? And we allow flame to go through it. At the end of the day, we see the water will evaporate into the atmosphere, and we'll have our salt on our dish. So that's how we separate soluble solids from a liquid. Next, we have decantation. This is a method used for separating a mixture of an insoluble solid and a liquid. So it's almost similar to filtration. It's similar to filtration. So the solid must settle distinctly at the bottom of the container, leaving the liquid at the top. So the difference between this and filtration is, for filtration, yes, the particle is not soluble, but in decantation there is a clear distinction between the liquid and the solute being in a mixture. So the liquid is decanted into a clean container, whereas we have what? Our solutes at the bottom. So this method is used for separating garri and water, magnesium trisilicate. We also use this method for separating that. Now let's look at crystallization and recrystallization. So this method is used for separating two salts with different solubilities. It is also used for the purification of a soluble salt that contains insoluble solid impurities. Pure crystals must be obtained from a soluble solid which contains impurities by recrystallization. So to obtain a pure substance by crystallization, the impure solid is dissolved in a suitable solvent, leaving the impurities as the insoluble residue. The solution is then filtered, concentrated, and recrystallized. Crystals obtained are thus the pure solid substance. Recrystallizing a solid increases the purity of the substance. Now, a solid substance may be purified from a solvent by crystallization. If it is soluble in the hot solvent but very slightly soluble in the cold solvent. So if we look at the diagram there, we have our solutes being mixed in our solvent. Now we notice that it is insoluble. It is slightly soluble in our cold solvent, but when introduced to heat, we saw that some of the particles as dissolved in our solvent, and it is later filtered into a bowl. So we leave it, and at the end of the day we get crystals of that solute. So recrystallizing those crystals, we get a purer form of our solute. That's just the summary of crystallization. Moving forward, let's talk about distillation. Distillation is the process of vaporizing a liquid and then condensing it. This method is used to separate two liquids with widely differing boiling points by evaporating from each other and recondensing in a separate vessel. The vapor that condenses and collected in a container is known as the distillate. For the manufacture of gin and distilled water respectively. When two liquids so the importance of distillation is it can be used to purify liquids. That is, we can get pure water from rivers or pond by this method. It can also be used to separate solute and solvent in a solution. So it's like an advanced form of evaporation to dryness. If we want the liquid in evaporation method, the liquid is being exposed to the air. But if we still want to get the liquid and the solute at the same time, we could also use the distillation process. Moving forward, fractional distillation. This method is used when two liquids have boiling points that are very close together, or when we have dissolved impurities in a required liquid that is volatile. So it is a modified form of distillation. Now, to separate the mixture of two immiscible liquids that have close boiling point, the less volatile liquid, that is the one with a higher boiling point, condenses more than the more volatile one, that is the one with a lower boiling point. The latter distill over the condenser and is collected as a distillate. So there you can, if in that diagram you can see what you can see, the first distillate and you can see the second distillate coming out. So that's about fractional distillation. Now let's look at, before that, let's look at the application of fractional distillation. It is used in the separation of air into oxygen and nitrogen. It is also used in the separation of crude oil into petroleum, paraffin, cooking gas, and the likes. It is also used in the manufacture of spirits, gin, alcohol is also used. Now let's look at precipitation. Now this method is used to separate metallic salt from their solution. That is, the ions are mostly what? Consigned. So in precipitation we are looking at what? The ions. Precipitation as a method uses the properties of differences in solubilities of solid in different solvents. If one substance is soluble and the other is insoluble, while the insoluble one settles at the bottom of the container as solid particles, usually known as precipitate, the insoluble substance can then be removed from the soluble substance by decantation or filtration method. Precipitation can be used for the purification of a solvent that can be added as an aqueous solution of a substance. So if the substance is insoluble in the second solvent added, the pure form of the substance is then precipitated. So looking at that diagram, we have what? We have the white precipitate of the insoluble salt formed when the two solution of soluble substance are mixed together. In step 2, we saw what? We saw filtration taking place there, and we have our precipitate on the filter paper and our filtrate at the bottom. So we are working with what? The filtrate. So the filtrate will the filtered precipitate is washed several times. So we use the filtrate to wash our precipitate several times. So the more we wash, the more we get what? The purified insoluble salts. So this method can be used for two purposes. Number one, it can be used for separation of substances. 2, it can be used for purification of substances. So we could purify the precipitate by what? By continuous addition of the filtrate to our precipitate in the filter paper. Once we continue adding the filtrate, we continue to get pure substance. So moving forward, we have chromatography. This method is based on the principle that if a substance containing a number of substance is allowed to pass through an absorbent medium, the different substance in the medium will travel at different rates and can then be separated out. So we have different types of chromatography. Number one, we have the paper chromatography, we have column chromatography, thin layer chromatography, and gas chromatography. So for the purpose of this class, I'm going to be talking about the first two, paper chromatography and column chromatography. So paper chromatography. This method can be used to separate leaf extract or ink. The absorbent material is a strip of filter paper, and the solvent used is what? Ethanol. So the leaf extract or ink is dropped on the filter paper and is allowed to dry. Then the strip of paper is then allowed to be suspended below the line in the test tube containing ethanol by corking the end of the paper. The solvent passes through the original ink spot and dissolves different materials in the ink mixture, which are carried by the filter paper and separate out in different colors. So each color is known as the chromatogram. So there is a diagram there on what I just described. Separation of what? Of ink. We can see ink there, and it is placed in what? It is placed in ethanol. And we can see when ethanol passed through the filter paper, we can see the different colors as spots, occurring as spots, and those spots are also known as chromatogram. Now moving forward, let's look at column chromatography. Now this is a type of chromatography that uses an absorbent in a column. This absorbent material include calcium trioxocarbonate 4, CaCO3. Then we have magnesium trioxocarbonate 4 or sodium trioxocarbonate 4. Aluminium oxide ion. Aluminium oxide, ionic exchange resin and gels can also be used. So the mixture to be separated is first dissolved in the appropriate solvent before it is passed down the column. The different components in the mixture are then absorbed by varying extent depending on their nature. So a strongly absorbent substance moves down the column slowly, whereas a weakly absorbent one passes through quickly. The mixture is then separated out as it moves through the column, and the components are colored. They are separated as visible bands. So it should be noted that the absorbent should be kept wet so as to allow easy separation of components. The components can be separated out by forcing the color zone out from the bottom of the tube one at a time, and each of these is recovered by using the appropriate solvent. So this method is effective if the right choice of absorbent and solvent are chosen. So we have a very simple illustration there of column chromatography. Sublimation. Okay, before we go to sublimation, chromatography can be used to analyze complex mixtures. For example, if you want to analyze chlorophyll, chlorophyll is the green pigment in plants. If we want to analyze chlorophyll, we could use chromatography to do that. It will separate into the different components and we could extract those components and look at them. So in the analysis of vitamin and protein, we also make use of this. In the analysis of some organic laboratory preparations, we use this. Then this method is also used in medicine. Okay, so sublimation. What is sublimation? Sublimation is the process whereby we are converting a solid to gas without any intermediary, without it melting, without any change of state to liquid. So the solid moves from solid to what? To gas. So some solid when heat changes from their solid state to gaseous state without going through what? The liquid state. So this type of physical change is known as sublimation. Examples of this include iodine, aluminium chloride, and sulfur. Solid which can sublime can easily be purified or separated from solid which do not sublime. For example, if a sample with some impurities is able to sublime, then the impurities which does not sublime is left behind in the heated container. Magnetization. Magnetization is used to separate a mixture consisting of magnetic and non-magnetic solids. For example, when I have iron filings and sulfur, I could easily put my magnet and all my magnetic solids will stick to my magnet, leaving sulfur behind. So the use of separating funnel. Separating funnel is used to separate two immiscible liquids. It's used to separate two immiscible liquids, for example, oil and water. I'm sorry, there's supposed to be a diagram here. I would work on it. There's supposed to be a diagram here. Probably I'll show you at the end of the video. So the mixture, okay, this type of separation technique involves two liquids that cannot mix together to form a homogeneous liquid. So this liquid will separate out into two distinctive layers that can be separated by a separating funnel. So the lower denser liquid layer is tapped off, leaving the upper less dense layer. For example, when we are separating oil and water. So looking at our separating funnel, we have what? Oil on top, water beneath, and you can see how we open the tap and allow the water to flow, and at the end of the day the tap is locked and our oil is left on the separating funnel. So this method is used for the separation of what? Two immiscible liquids. Centrifugation, pardon my English. So centrifugation is a process whereby a machine known as a centrifuge can be used to spin test tube containing suspension at high speed. So after the spinning, the heaviest particle settles at the bottom of the test tube, while the clearer solution separates out at the upper layer. And next we have winnowing. Winnowing is a method used to separate mixtures of two solid particles one being lighter than the other, by blowing of air to remove the lighter ones. For example, when we want to separate beans from shafts, we just blow the lighter shaft and we get our beans. Precipitation. Precipitation can be carried out by mixing two different solutions which reacts to produce one soluble compound and one insoluble substance called the precipitate. So for example, when we have copper copper 2 tetraoxosulfate 6, when a solution of copper 2 tetraoxosulfate 6 is added to sodium hydroxide, a soluble sodium tetraoxosulfate 6 solution is noticed, and an insoluble copper 2 hydroxide, which is also known as what? The precipitate. So the precipitate can be separated from the solution by filtration, decantation, or what have you. So thank you for sticking to the end. Next, we are going to be talking about precipitation can be carried out by mixing two different solutions which reacts to produce one soluble compound and one insoluble substance called the precipitate. So for example, when we have copper 2 tetraoxosulfate 6, when a solution of copper 2 tetraoxosulfate 6 is added to sodium hydroxide, a soluble sodium tetraoxosulfate 6 solution is noticed, and an insoluble copper 2 hydroxide, which is also known as what? The precipitate. So the precipitate can be separated from the solution by filtration, decantation, or what have you. So thank you for sticking to the end. Next, we are going to be talking about